In this video, we're going to do an example of simplifying resistor networks, and in particular, we're going to focus on networks which can be simplified by a bunch of series and parallel combinations. Now, not all networks are like this, and in some more advanced networks, you might have to use what's called a delta Y transform to simplify them, or you can just throw it at a computer and the computer will tell you. But we're not going to focus on these types of networks in this example. So here's the problem statement. We want to find the equivalent resistance to the left of this voltage source. And so we want to figure out how to simplify this resistor network into just a single resistor. So how do we start? Well, usually in these types of networks, there's a weak spot. There's at least one place where you can do a series or parallel combination. And so I see one weak spot in particular. I see that this resistor and this resistor are in parallel with each other. And, they look kind of horrible because they don't look how parallel resistors usually do, but they're connected at one end and they're connected at the other end. So they are, by definition, in parallel with each other. And for this network, let's say that all resistors have a value of R currently as they're drawn. So if we take these two resistors and combine them in parallel, because they're the same value, we'll get one which has a value of R over 2. And I'll draw that in green. This will be our new resistor, R over 2. And we can clean this up a little bit so we can make it so it looks a little nicer. So we can look at our network and we can see that, this isn't some horrible mess anymore. And I do recommend that you physically redraw the network each time you simplify a resistor, either if you're using a tablet on the same drawing or that you redraw it below if you're using pen and paper. So now where can we simplify this network? Well, I see that, again, we've got a resistor right here, which is in parallel with one right here. So they're connected at this end and they're connected at this end, so they have to be in parallel with each other. And so if I want to add them, I need to add their inverses. So 1 over my equivalent, my new resistance, is going to be 1 over R plus 1 over R over 2. This is equal to, 3 over R? And so my new resistance for the parallel combination of these two resistors is just R over 3. And so I'm going to erase this one and replace this one with a value of R over 3. And now this network is starting to look a little simpler. And the next simplification I can do is that this resistor, and this resistor are all in series with each other. And so my new equivalent resistance, so my equivalent resistance for those resistors is just R over 3 plus R, which is 3 over 3, 6 over 3, so 7 over 3. And so I'm going to erase these two resistors. And my new resistor is the combination of all three of them, which has a value of 7/3 R. Now we've only got one more step to do. So this resistor we now see is in parallel with this resistor. And if you want, we can redraw it to make that a little more clear. So they're connected at both ends. So they're connected at the top and they're connected at the bottom. And that's all you need for two resistors to be in parallel. And so their equivalent resistance, 1 over Req, is just 1 over 7/3 R plus 1 over 1R. So 3/7 plus 7/7, all times 1 over R, which is 10/7. And so, or 10/7, 1 over R. And so the equivalent resistance of those two is just the inverse of that, or 7/10 R. And so I can replace these with an equivalent resistor, and I'll draw this one in green, that has a value of 7/10 R. And this is my final answer. So by just identifying what I like to call a weak spot in the network and then making one simplification after another, we can eventually get to the correct answer. Finally, I'd like to thank all my patrons on Patreon. Your support is greatly appreciated, and it is you who makes these videos possible. If you aren't currently a patron, to get early video access, behind-the-scenes footage, exclusive content, and join a like-minded community, click the link on screen or in the description below. Thanks for watching.